Good people, today we'll be doing this function, which is a straight line function. But now the very important thing about this function is contains some inverses. So the first question that we need to do from here is just finding the x-intercept. From now, x-intercept is probably the work from grade 10 of the straight line, and also in grade 9 that work has also been done there. Now finding the x-intercept, remember now they are telling us that our function, which is the f at x, is equals to negative 2x plus 5. Then how do we find the x-intercept? Finding the x-intercept, we let our y is equals to 0. Now letting y here, it's going to be y is equals to negative 2x and then plus 5. Now finding x, take 5 to the another side, it's going to be negative 5 equals to negative 2x. Now divided by 2, and then this cancel each other, meaning my x-intercept, it's going to be 5 over 2. So from this graph, this point that it's here, which is my x-intercept, is going to be 5 over 2, the x-intercept of that point. So that point, if I can name that point as r, that point is just going to be 5 over 2 map 0. Now let's go to the second question, which is B. Now on B, they are telling us let's find the domain. Now the domain of this graph, remember they've told us that the x is an element. Now they're putting these big brackets here, meaning our graph, it starts here and it ends here. As much as you see the other line continuing on that side, but from this restriction that they've told us here, meaning our graph, the end point, it starts here and then it ends here. That is the end point of this graph. So the domain of this graph, is just x is an element, which is the restriction that they've gave us here. That's where the domain started 4 and then it's ended what? At negative 4 and ends at 3. There is a domain of the graph, which is the restriction that they've already gave us. Another notation that you can use is where you say your graph is negative 4 less than or equals to x, or less than or equals to 3, where x are the element of real numbers. That's another notation that you can do if you're finding the domain of this graph. Now C, they're telling us let's find the range. The range is meaning where the y values are existing. The y values where they are existing, remember they've told us that this function starts here and it ends here. So the range of this graph, it's going to be the y coordinates of these points. So the y coordinates of where the graph started, it's 13, and the y coordinates of the graph where it ends, it's negative 1. So the domain, which y is an element, now the domain, the y of where it started, to start at what? At 13, and then it ends what? At negative 1. These are the y coordinates of the where the graph starts and where the graph ends. I hope we can see that one also. Now let's find another notation of this thing. The notation that we can use more or less the same as this one. It's where the 13, it's less than or equals to y, and then it's less than or equals to the negative 1. That's where we can use also that one. But remember now, this one we can't use it like this, since this number is less than what? 13. So we can say negative 1 is less than or equals to y, and then less than or equals to 13. It's very important that you start, when you're using this notation, you start with the less than number. Now there's something that I want to show you here, because the following example, or the following question, is to find the domain of the inverse and the range of the inverse. Now remember, it's very important. going to draw a table here. I'm going to write to D for domain, and then a range, R for range. This is going to be F, which is my original function, and then this is going to be my F inverse, which is the inverse of the function. Now we've already found the domain of what, of the original function, where it says -4 less than or equals to, or less, or x, and then less than or equals to 3. And then we found the range, which is -1, which is less than or equals to y, and then less than or equals to 13. And then now finding the inverse, or the domain of the inverse. The domain of the inverse, it's gonna be the range of the original function. And finding the range of the inverse, it's going to be the domain of the original function. I hope you see this one. So now the range, or the domain of the inverse, it's going to be -1, but remember now we are looking for the x values because it's a domain. So it's going to be x, and then less than equals to 13. And now finding the range is in terms of y, so it's going to be y, which is going to be less than or equals to, and also less than or equals to, but it's going to be -4 and 3. I hope you can see that one. And then another notation that we did, it's more or less the same thing. It's still D and R, which is the element of real numbers, where -4 map 3, which is the domain of the original function, and then the range of the original function was -1 into 13. Now remember, now the range, it's a domain of an inverse, so it's x into an element of -1 into 13. And also now finding the range of the inverse, now it's going to be the domain of what, of f, so it's going to be y into the element of -4 mapped to 3. It's an opposite. Remember, the range, or remember, the inverse is an interchange of x and y. What was x is going to be y, what was y is going to be x. The inverse, it's always the interchange of x and y. So it's very important that you understand, if we have found the domain of the original function, the domain of the original function, it's going to be the range of the inverse, and then the range of the original function is going to be the domain of the inverse. It's very, very, very critical that you understand that one. So I've already answered the question that was asked here, which was finding the range or the domain of this one, and also finding the range of this one. Now the question that is following that now is to sketch the inverse. Sketching the inverse, now I've just talked about the interchange of x and y. We're gonna have f, and then we have f inverse. Now we're gonna have an x-intercept. And then we're gonna have the y-intercept. And then we're gonna have our endpoint. Remember, in this graph, we gave us the endpoint, so it's where the graph ends. So from my original graph, the x-intercept, remember I already found it there, which was 5/2 map 0 which is 5 over 2 is like 2 comma 5 into 0, and then here y-intercept was 0 comma 5. Remember, my function was y is equals to negative 2x plus 5. This is a y-intercept. And then my endpoint, which was negative 4 map 13, and also 3 map negative 1. This was my coordinate of the end point. Now remember, inverse is an interchange of x and y. So now finding the x-intercept of the inverse is going to be a y-intercept, and then finding the y-intercept of the inverse is going to be the x-intercept of the original function. So this is going to be 5 map 0. The y-intercept of the original function is going to be the x-intercept of the inverse, and then the x-intercept of the original function, it's going to be the y-intercept of what? Of the inverse. So here 2 comma 5 map 0, it's going to be now my y-intercept. I hope you understand that one. And then from here, it's just going to be the interchange of x and y. Now here, it's going to be 13 map negative 4, and then here it's just going to be negative 1 map 3. Guys, it's very important that you understand this one. Very, very, very important. You can draw the table of finding the inverse of this thing and also check from there. And then if you understood this one, let's go let's plot our graph. I've already plotted our graph in GeoGebra. So this is my inverse. So the red function, which is my inverse, is going to be this one. And then this is my end point. And then this one is going to be my end point. And also now remember, this one here is going to be my y intercept of the inverse, which is the red one. And then yeah, that's all. And also this is my x-intercept of now of the inverse. Remember, this x-intercept, while it was a y-intercept of the original function, which was here, which is this is my original function, which was 5 map 0. I hope everything it's clear, guys. If you don't understand it, I don't know, but yeah, I hope I made everything clear. This is the inverse function. The inverse function, it's a reflect based on this equation that is here, which is y equals to x. The inverse function, it's a reflection of this line here, which is y is equals to x. Thank you so much, guys, for watching. Makebal.